What would you think if I told you there was a frozen galaxy that moved through space like a living fossil? The James Webb Space Telescope discovered a galaxy fossil that had been preserved for billions of years. Despite not creating new stars for eons, the galaxy is still intact and unchanged. These fossilized galaxies reveal the secrets of the universe. Fossil galaxies are relics filled with old stars that stopped forming new ones centuries ago. They are like ancient witnesses to the early universe, giving scientists clues about how galaxies changed over time. These galaxies often originate from large clusters of galaxies left behind by galaxy mergers. But why are some galaxies frozen in their early development? What stopped their growth and how do they survive today? These unchanging galaxies give us a glimpse into the early stages of the universe, about which we know little. Thanks to the James Webb Telescope, we can finally see the hidden details of this primordial era. The telescope has astonished us with numerous discoveries revealing the cosmic events that shaped the universe. But fundamental questions remain. How and why galaxies formed, and how were their shapes determined? Now scientists have been studying distant galaxies since the dawn of time. With the recent discovery of the dinosaur galaxy, the James Webb Telescope is expanding our understanding of galactic evolution. These ancient galaxies formed early in the history of the universe. Billions of stars were born in a rapid phase of star formation, forming amazing spiral shapes in record time. But then star formation slowed down almost abruptly, maintaining the structure for billions of years. Amazingly, these galaxies are still visible today. Dark matter, dark energy, and gas distributions can preserve these fossils, even though they are no longer actively forming stars. Fossil galaxy NGC 1277, located in the Perseus cluster, is an example of such ancient preservation. This galaxy is unique because it has not changed much since it formed billions of years ago. Thanks to the advanced infrared capabilities of James Webb, we can now peer through the cosmic dust that once hid galaxies like NGC 1277. The telescope has revealed distant worlds that Hubble could not see. NGC 1277 was first discovered by Hubble and is located about 220 million light-years from Earth. Most of the stars in this galaxy are ancient, with more than half of them being between 10 and 12 billion years old. Interestingly, NGC 1277 has not formed any new stars in its long history, and its stars are mostly low in metals, reflecting the composition of the early universe. This low metal composition reflects the state of the universe just after the Big Bang. Some scientists have theorized that some unknown force or process may have frozen these galaxies in time, stopping their growth but allowing them to remain stable. Even more mysterious is the fact that at the center of NGC 1277 lies a massive black hole, making up about 14% of the galaxy's total mass. The immense gravity of this black hole could affect the fate of the galaxy, limiting its ability to form new stars and grow. Interestingly, unlike other ancient galaxies found in dense clusters, NGC 1277 is located in a relatively isolated region with few neighboring galaxies. The James Webb Space Telescope has also captured Einstein rings, a phenomenon predicted by Einstein's theory of general relativity but rarely observed. In simple terms, Einstein rings are a type of gravitational lensing effect, but instead of creating a magnified arc, they form a perfect circle of light. Webb's instruments have now detected an Einstein ring around the distant galaxy SDSS J 1226-2149, visible through Webb's sensitivity to faint cosmic signals. This effect causes light to be stretched into a ring as it passes through a massive object, magnifying distant objects behind it. Gravitational lensing allows astronomers to observe objects much farther away than would normally be possible, expanding our ability to study the earliest stars and galaxies in the universe. The first Einstein ring discovered was in the A370 galaxy cluster. Not only does this cluster contain Einstein's amazing ring, it is also proof that Einstein's predictions were accurate. Since then, gravitational lensing has allowed astronomers to observe incredibly distant galaxies, such as GNZ11, one of the oldest known galaxies. GNZ11 is about 13.4 billion light-years away, and its light dates back to just 400 million years after the Big Bang. Gravitational lensing allows scientists to study ancient stars and elements, revealing the composition of galaxies just after the universe began. Even Hubble was able to detect GNZ11 thanks to this lensing effect. This lensing phenomenon also led to the discovery of Max J 11492223, the most distant single star ever observed, located in a galaxy about 9 billion light-years away. Gravitational lensing amplified the light by more than 1,000 times, allowing scientists to study this single star in detail for the first time. Webb's unprecedented capabilities now allow astronomers to decipher the light signatures of stars like Max J 11492223, profiling the gases and elements that make up the earliest stars and galaxies. With each discovery, Webb continues to reveal fascinating new perspectives and hidden details of the universe as it unfolds over billions of years, bringing us closer to unlocking the secrets of the universe's early days. This new window into the universe's past doesn't just show us galaxies. It opens our eyes to the forces that shaped them. Now, scientists believe that gravitational lensing and the James Webb Space Telescope will eventually allow them to discover two of the most mysterious substances in the universe: dark matter and dark energy. These two forces make up about 95% of the universe, yet we understand very little about how they work. What we do know is that they influence everything from the formation of galaxies to the ultimate fate of the universe itself. Fossil galaxy NGC 1277 and Einstein's ring offer a glimpse into the strange interplay between visible matter and dark energy. In some ways, they serve as natural experiments, helping scientists test theories about galaxy evolution, gravity, and the role of dark matter. Studying these ancient structures could one day provide insights into why our own galaxy, the Milky Way, evolved the way it did. The capabilities of the James Webb Space Telescope are also changing what we know about black holes. Traditionally, black holes have been thought of as cosmic destroyers, devouring everything in their path. But recent discoveries suggest that supermassive black holes, like the one at the center of NGC 1277, may also play a role in stabilizing galaxies, especially fossilized ones. These black holes could be important factors in maintaining the delicate balance of galactic structure even as other galaxies evolve and change. Webb's discovery showed that black holes can be gigantic engines of stability. But why should they prevent the formation of new stars rather than trigger them? Scientists are now exploring the theory that black holes can exert overwhelming forces on their host galaxies by heating and pushing away surrounding gas, preventing the formation of the cold, dense regions necessary for star formation. The discovery raises new questions about the role of supermassive black holes in the life and death of galaxies. The James Webb Space Telescope continues to change our understanding of time and distance in the universe. Webb used gravitational lensing to allow scientists to observe some of the earliest galaxies and, surprisingly, individual stars billions of light-years away. The telescope isn't just a tool to look back in time. It's a way to map the structure and growth of the universe itself, layer by layer. As Webb photographs these ancient relics, he also explores the atmospheres of exoplanets in unprecedented detail, looking for planets that might have the right conditions for life. He tracks the composition of the gases around these planets, looking for signs of water, oxygen, and other elements necessary for habitability. Could there be other worlds where life developed in completely different ways? Telescopes have also revealed incredible details about the planets in our solar system. For example, Webb has taken high-resolution images of planets like Jupiter and Saturn, revealing details of their atmospheres and surface features in ways never before seen. By observing how these planets reflect and absorb light, Webb can help scientists understand their climate patterns, chemical composition, and even their history. And beyond the planets, telescopes study asteroids and comets, providing data on the primordial material that formed our solar system. Webb's observations can show how these rocky bodies evolved over time, providing clues to the early components that eventually led to planets like Earth. In a sense, these objects are themselves tiny fossils, remnants of the formation of our solar system 4.5 billion years ago. But it is the distant galaxies frozen in time that continue to capture our imagination. Fossil galaxies like NGC 1277 and ancient structures like the Einstein ring remind us that the universe holds secrets far beyond our reach, yet tantalizingly close through the lens of the James Webb Space Telescope. Who knows what other secrets Webb will uncover as he continues to peer deeper into space? Perhaps it will shed light on how the universe itself came into being, or even hint at other worlds beyond our own. Ultimately, everything Webb has discovered, every distant star, every ancient galaxy, every flicker of light from a long-dead star, is creating a clearer picture of our universe's origins. It's a profound reminder that the universe is much older, more magnificent, and more complex than we can imagine. And with each new image, the James Webb Space Telescope brings us one step closer to understanding not only where we came from, but also what the future of the universe will bring.